In question number 18, we have again sine and cos, so we can easily use substitution here. Now, when we choose our substitution, we always should choose our u as our embedded function. And whenever we have the constants, in this case plus 1, we should try to incorporate that into our u. So I've incorporated the plus 1 into the u. And the reason why we do this is because when we differentiate to get the du, the 1 differentiates to 0, so I end up with 2 cosine theta d theta. Okay, so I'm going to replace, I have my cosine theta d theta, the outside function being accommodated by the derivative. I'm just going to rearrange this derivative. Du over 2 is equal to cosine theta times d theta. And I'll do my substitution. So I have my substitution. Again, I change my bounds to u. U equals 0, x. I have to state that my bounds are in terms of x. X is 0. X is equal to pi over 6. And we end up with our du. And I'm going to put the 1/2 on the outside. And in the denominator, I have the whole u. So now I can integrate this. So when I integrate this, I end up with 1 over 2. This is going to be log of u. And the bounds are going to be from x equals 0 to x equals pi over 6. So again, I want to substitute and express this in terms of theta. So I end up with 1 plus sine theta, 1 plus 2 sine theta. That represents my u function. And now since I have it in terms of theta, and maybe I should state this with theta here. Theta equals pi over 6. Theta equals pi over 6. And I can express this in terms of theta of 0 to pi over 6. Maybe I'll just do this properly here. We should really state that as theta. And then now I can just substitute in my theta. So I'm going to keep the 1/2 out. So I end up with log. Sine of pi over 6 is going to be 1/2. So I get 1 plus 2 times 1/2. So this becomes log 2 minus log. I'm going to plug the 0 in. Sine of 0 is 1. Sine of 0 is 0. So I end up with log 1, which is 0. So then the final answer is going to be 1/2 log 2 minus 0. So that's just going to be 1/2 log 2. So we end up with e, because we need to rearrange this into log, and then the exponent 1/2 goes into the log. So this is how we get the answer e.